Okay, a real quick video on what we call the Pythagorean, or what I call the Pythagorean trigonometric identities. Okay, some people say Pythagorean, I say Pythagorean, tomato, tomato. These are, they look like formulas. You can call them formulas if you want, but they are identities that will always be true. This relationship will always be true for any angle. Okay, on the unit circle, coterminal angles on the unit circle, whatever. If you take the sine of an angle and square it, now let's talk about this notation real quick. This is kind of odd looking, right? What this is a shorthand way of saying sine theta squared, okay? And this is one of those trigonometric functions that we can use the unit circle to help us find, right? So really this statement says this, but to simplify it, they take the parentheses out and put the 2 here in between these two terms. So understand what that's saying. And just as a quick example, and so this relationship will always be true for any angle on the unit circle, as will this, as will this. So these are 3 different, we call them identities, right? They're quote unquote formulas. They're properties that we can use to help us solve for certain things. Okay, so but just as a real quick example, what we're talking about here, let's take a 45-degree angle, just as an example. Okay, you know that for the 45-degree angle, the coordinates on the unit circle are radical 2 over 2 and radical 2 over 2. Okay, so if we take this identity, okay, just as one example of how this works, and again, this really means the sine of theta squared. So stay with me. I'm going to write quickly. You can pause this at any time if you need to. Okay, if we say, what's the sine of 45 degrees? All right, now this theta and this theta have to be the same. If they were different, we'd probably give them subscripts. Take a look. What is the sine of 45 degrees? The sine of 45 degrees is the y coordinate. So I'm going to replace this with radical 2 over 2 because that's what the sine of 45 degrees is equal to. What is the cosine of 45 degrees? The cosine of 45 degrees is the x coordinate, right? So this is radical 2 over 2 squared. And if I add these together, I should get 1. When we square radical 2 over 2, we square the radical 2, which is 2. We square the 2 here, which is 4. And we add that. We square the radical 2 here, that's 2. We square the 2 down here, that's 4. Is 2 over 4 plus 2 over 4 equal to 1? Yes, it is. So this is just one example of how this works. We can replace, if we know a sine value, we can replace the entire trigonometric package with that y coordinate. Similarly with cosine, if we know what the x coordinate is of that angle, we can replace that with that value, and then we can verify it. Now this is going to get used to solve something in the next video. Okay, so we're still going to be using this idea, but we're going to use it to solve for something that we're missing. This is just us validating that it actually works, okay? Just as a quick example.